Before we begin, let's talk about prerequisites. You first need to have a Proxmox instance, ideally a fresh installation of Proxmox, and for this demo, we'll be using Proxmox version 8.x. If you're running an older version, this will still work, but you'll skip the optional script 0 initial setup. I'll go ahead and create my Proxmox host now. In my case, it's going to be a nested virtual machine in a VMware environment, but the process outlined in GitHub would work the same whether it was a physical Proxmox host or a nested VM. In either case, you would need the Proxmox ISO downloaded from their site. Now, it's best if your Proxmox instance has about 500 gig free, or at least 300 gig minimum. My Proxmox instance will have 48 gig of RAM, but that should give us 42 gig to allocate, that way there's some left over for the hypervisor host. Now, there's a couple of VMware specific settings since this is a nested virtual machine. We have to expose the hardware to assisted virtualization on the CPU. There's also a specific networking setting we have to turn on for nested virtualization, that way the networking on the virtual machines will be routed. We can see these settings turned on here. Now I'll go ahead and quickly install Proxmox. And in my environment, my network is 192.168.100, so I'll go ahead and make it static at 152. While Proxmox is installing, let's explore my GitHub README more. What we're going to be building within Proxmox are Ubuntu VMs that host a Kubernetes cluster. After we set up Proxmox, we'll set up the VMs, then we'll set up Kubernetes. Then after Kubernetes is installed, we'll install a UI to manage Kubernetes called Rancher. After we have a working UI, we'll install Nextcloud as our test Kubernetes application. And then finally, we'll remove that test instance and redeploy Nextcloud, but this time with persistent storage and a MySQL database for a robust production-ready deployment. It sounds like a lot, and it is, but the scripts will guide you through it. It's a lot like building a house. You first have to pour the foundation, then build the frame, the exterior, the interior walls, drywall, and so on. Each builds another layer on top of the existing. Now let's check in on our Proxmox install. Looks like it's still going. Back to our README. Now, the README has a lot of information, which shows step by step what we'll be creating. But another resource that may be useful is an outline that shows a condensed view of our order of operations. That way we can see everything on one page. Now back to the README. If we scroll down a little bit more, we can see that there's a shortcut script. This shortcut script lets us copy one line of code to get the process going. I'll click copy, so now that's in our clipboard. And now let's check on our Proxmox install. It looks like it's finished, so we can browse to it. And we'll go to our Proxmox shell, and I can paste in that shortcut script. It shows that we are currently at the shortcut script, which is actually a step above script 0 or 1, but then it will let us choose which script to start with. Script 0 is an optional script to initialize a fresh installation of Proxmox. In general, if your VMs have a lot of I/O, you'll get better performance by creating a thick provisioned LVM rather than using the default thin provisioned local LVM. This script also adds the non-subscription repository to Proxmox, which allows you to upgrade it to the latest build of 8.x. Now, since this is a home lab, it's totally fine to use the non-subscription repository. But if this was a production environment, you definitely want to have the purchased version of Proxmox. Now, script 1a is where we actually start the process to build things. First off, we want to keep our root user clean. So that's why the shortcut script and scripts 0 and 1a will be the only scripts that are in the home directory of the root user. Everything else after that point will be done as a different user called Ubuntu Prox. The other reason we're using a different user is that in script 1b, we'll be generating an SSH key for remote access to the VMs we'll be building. We want to not expose our root user, so we'll be using the Ubuntu Prox user instead. Now, I'll go ahead and pick yes to run script 0. If you simply follow the default settings of a Proxmox installation, it will use the full amount of your disk, so you won't have any unallocated space. That's okay in this scenario for testing, we just won't be able to create a thick LVM. The script will ask if we want to, and if we pick no, that part will be skipped. But if we pick yes, it will attempt to create it. But it'll essentially skip over creation as it sees there's no unallocated space. If we had unallocated space, it would create a thick provisioned LVM. Notice how the warning says repartitioning is probably a bad idea. But in our scenario, we wouldn't be changing any of the existing volumes anyway, only adding a new one. But since we don't have any free space, in this instance, we can't do that anyways. Hey, Ben from the future here. Another thing I did want to show is a Proxmox nested installation, but this time with some unallocated space. So I'll install Proxmox here, but in this case, so instead of using the full 300 gig here, I can change this and specify a smaller size. Now we do need a dedicated amount still for our Proxmox instance. Let's pick something still reasonable, maybe like 60 gig for the OS. We'll split that in half and say maybe 30 gig for the VZ side of the full hard drive. Okay, now I'll click next. And I'll also make this at 152. Now that Proxmox is installed, but this time with some unallocated space, I can log into it. Now if we go to our shell, I can paste in the code from GitHub. Now we're back to the shortcut script. And now I can start with script 0. And this time we'll use our unallocated disk space. And for this part, I'll skip the updates. Now if I expand, I can see that I have a thick LVM. And I have 257 gig available in this thick LVM to use. Part of our OS drive is the VZ volume, which ISO images and backups can be stored. And then the other part is the local LVM for the thin provision storage if you wanted to have it. Now, this was just a demo to show the thick LVM creation. For the rest of the videos, we'll actually be going back to the original nested Proxmox VM, which only has the local LVM. Now, since this is a fresh install of Proxmox, we need to update it to the latest version. But also, since this is a fresh install, in order to be able to update it, we have to add the non-subscription repository. The next part of this script modifies the sources.list file to enable this. I'll go ahead and pick yes. Next, it will run some updates, which will take a few minutes. And after the update, we'll have to reboot our Proxmox host. While we're waiting, let's go ahead and go back to our GitHub README. So we already did step 0, and once our Proxmox instance is updated, our next step will be to run script 1a, which is to create a separate user called Ubuntu Prox. After we have that separate user, then we can generate an SSH key for it and download additional scripts. From that point forward, we'll be logging in as Ubuntu Prox. Then we start to build our VMs. We'll create a VM template, and after that VM template is created, we'll create multiple VMs based on that template. After the VMs are deployed, then we check for updates, copy that same SSH key, but this time to the first VM that gets built, which is known as our admin VM. And then from that point, all scripts will be ran within the admin VM. Then in step 3, we install Kubernetes. This is essentially the script from Jim's garage, but with a few modifications. After we get Kubernetes up and running, we add all of our nodes or VMs other than the admin VM to join our cluster. Then we install a load balancer and then get things running so we'll have a test Hello World deployment. After step 3, managing and monitoring Kubernetes exclusively from the command line may be a bit difficult, and that's where the Rancher UI steps in. Once we have better visibility into our Kubernetes cluster, then we can deploy a test workload. But this workload uses what's called an ingress, which is heavily dependent on having DNS working. We have to have a domain that's resolvable within our network. So in script 5a, we'll deploy a local DNS server. Once we have a domain that resolves, then we can test our Nextcloud installation. After we've proved we have a test application that works, then we can deploy a production-ready version of it here on step 6. Now again, I know this looks like a lot of steps, but the scripts will guide you through it. Let's go ahead and check on our Proxmox update. Excellent, it looks like it did update, so now we can type in reboot. And we'll wait for our Proxmox host to come back. It may take a minute or so for it to fully come back. Excellent, so our Proxmox host is back and we can see that it did update to 8.4.1. And we can go back to our Proxmox shell. I'll go ahead and type in ls. So we already ran script 0 and now we can run script 1a. I'll go ahead and type in period, a backslash, and then copy the name of this script 1a. Paste it in. Now it downloads the sudo package for our new user, so our user can run with elevated permissions. And then the next thing it says is, hey, your Ubuntu user password is still set to the default in the script. We need to edit the script to change that default password to something custom. We'll go ahead and edit it. So I'll type in nano and the name of the script. So we need to edit this to have a custom password for our Ubuntu prox user. I'll go ahead and type in something super secure like p@ssw0rd, exit and save it. Now we can run it. Excellent, so now it's switched to our Ubuntu prox user. I can type in ls. We can see that it downloaded a new script called script 1b. But generally, it's a good idea to review what the script does before we just run it. So I'll go ahead and type in nano, highlight the name of that script, copy and paste it. And it looks like there's actually nothing we have to define here. It confirms that we're logged in as our Ubuntu prox user and downloads additional scripts and then generates an SSH key. I'll exit out of the script and let's run it. Excellent, so it generated an SSH key. Let's copy this public key so we can refer back to it. We'll go ahead and hit copy. Now we can continue on to script 2a. I'll go ahead and type in nano and highlight script 2a. 2a is where we build our VM template. Now we have to define our password again, and the reason for that is this will be the password for our VMs that we end up building. So if we scroll down to step 2a.5, we can see it defines a user called Ubuntu, which is different than Ubuntu prox, and it will have the password CIPass, which is defined up here. CIPass equals password. So in this case, for simplicity, I'll go ahead and make the password here the same as my Ubuntu prox password, but they could be different. And let's save and run it. So the first thing it does is it downloads an image of Ubuntu called Jammy. After that image downloads, then it extracts it and it creates a VMID 5000 and creates a template based off of that. It adds in our SSH key to this template, and then it added an additional 6 gig to this 2.2 gig image file. Now we can go ahead and review what it created. So if I click here and go to hardware, we can see that we do have a disk image that's about 8 gig, and we can see that we have 4 gig of RAM and 2 CPU sockets. And if we go to this cloud init section here, it did create a user called Ubuntu. And if we edit our SSH key here, we can see that this matches this. Pretty cool. Okay, so I can close out of that and go back to our Proxmox shell.